Again, and welcome back to the fourth and final chapter in the Cisco Live session to troubleshoot the Catalyst 9800 wireless LAN controllers. In this chapter, we will be looking at some of the health monitoring and key performance indicator monitoring commands that you can look to identify if your system is doing well or if there is any problems it is facing so that you can proactively work towards resolving them. We will also conclude with some of the key takeaways from our session today. Now, hardware monitoring. On an appliance, there is a whole set of sensors that are available to monitor voltage, temperature, etc. The data from all these sensors is available in a singular output called show environment all, which will help to let you know if there are any hardware issues you are due to face. On a virtual appliance, while there is on a virtual deployment, while there is no real hardware sensor to be monitored, you do have the output to get a sense of how many CPU cores are in use, how much hard disk space has been aligned, and what sort of hosting environment you are in. In this example, it's a VMware hypervisor, but if there were other hosting environments, those would get visible as well. Now, the first most important entity as far as providing wireless service off of the 9800 is concerned are the access points. So the next few slides are going to talk about the AP health and how to validate that. First, we have the show wireless stats AP discovery command, which will give you a single view into all the APs that are trying to discover this controller. In addition, we can look at the AP reliability by looking at show AP uptime to see if there are any APs that are crashing, or by looking at their uptime, or if there are any APs that are experiencing cap-up tunnel flux by looking at their association time. You can also verify the join statistics for the AP by looking at show wireless stats AP join summary. In this output, you will get multiple data points. One is to see how many APs are joined and which ones are failing to join, the reason code for why they are failing to join. It will also provide you the base radio, the Ethernet MAC, and the IP address, which can be used to further debug the reason for the join failure. In addition, we also have the DTLS connections command, which provides an input into how many connections there are per AP. It will also let us know what ciphers are in use, and in case of NAT and PAT, it helps to identify the source ports. There is also in addition a history command, which gives you a view into the last few APs that have been failing. It will let you know how often the APs are failing, the reason for why they are failing, and you can potentially diagnose the failure reason even without having to run any single debug. Now, we talked about how once a control plane has processed an AP join, the AP entry has to be plumbed through the various components to program the hardware. These are some of the outputs that give you a view from the different components. The first one is the WNCD's view. The R0 would be the FMAN IP. F0 would relate to FMAN F0. And then the CPP client, which is nothing but the ASIC driver that programs the eventual data path for the entry. As you can see, we also have the mobility tunnel being shown in the same outputs because that's a CAPRAP DTLS tunnel as well. Now, the APs can also be troubleshot in a much easier way by simply leveraging the GUI. Let's take a look at this quick demo to identify how. First, you can go to the dashboard, look at the join summary. By clicking on it, you will get details around the join statistics. By clicking further into the AP and going to the statistics tab, you will be able to see the statistics for different phases, the control phase, the join phase, configuration phase, and you will be able to identify this AP failed due to a regulatory domain check failure. Now we want to know exactly what that means. So what you can do is use the gear button and choose the two MAC addresses so that they show up under the radioactive trace for debugging. Now you go ahead and start the RA trace, attempt to rejoin the AP, then go ahead and stop that. And by hitting the generate button and looking at it over the last 30 minutes in this case, you will be able to derive an RA trace for that AP that provide a more contextual data as far as the failure. As you can see, the trace was generated, which is downloadable. And once you have the file, you can look at the details and identify what that regulatory domain failure was all about. Was it that a country code had not been configured? And that really is the case. As it says, country code US is not configured on the WLC, which is why the AP would not try. So really, without ever having to go to the CLI and run any complex commands, we are able to identify uh, a lot of detail and troubleshoot the AP join process. Now, the next big entity on the wireless network for us is the clients. And client health monitoring is of utmost importance to know how what kind of service your wireless service you're able to provide to your end users. For client health monitoring, we have one super command. It's called the show wireless stance client detail, a single command which will provide a view into everything that is going on in the box. The first data point it provides you is to give you an idea of how many clients they are connected to the network. Furthermore, it will list the clients and by distributing it per protocol, how many 802.11ac clients are connected, how many 11ax clients are connected on the 5 GHz radio, 2.4 GHz radio. These you can verify easily. You can also identify the client summary based on the client state, how many of excluded clients, how many are anchored clients, and so on. The second part of this output presents the global statistics on the client. This includes like association requests, how many broadcast rotations happen, how many EAPOL keys got sent and received, add mobile center and received, any AID allocation failures, roaming sort of scenarios. So very easy to spot when you see incrementing numbers. That's a good indicator to see a particular type of statistic or failure condition, like frequent broadcast rotations happening, a lot of allocation ID failures. Those are all quick ways to indicate that there's a problem going to happen in the network. The third part of this command provides you the state statistics. So basically, it will tell you average time that the client spent in a particular state. So if you see that in this example, the IP learn state is where the client is spending a lot of time. That increasing time or that increasing average time would be an indicator that the DHCP process is experiencing some congestion, and it might be something where you can go look at the network and identify between controller and the DHCP server what sort of path you have and what you can do to alleviate the congestion. It will also help you identify any performance problems. So if there is a latency variation over time, that will be another indicator that there is a performance problem coming up. The fourth half of this command has a lot of web statistics. It not only tells you about what statistics, what HTTP requests were, or how many HTTP requests were intercepted. It also has a counter against how many different web HTTP status codes were seen, like for HTTP OK or HTTP to accepted, and so on. The fifth part of this command has some back pressure queues. So in the scenarios where due to pending SSL handshakes or due to a pending AAA reply, when the webauth cannot complete and you see SSL exhaustion, those sort of issues can be easily troubleshot by looking at the statistics. It also presents a view into Totonic's global statistics. So any sort of radius meltdown sort of scenario, if you are going to trigger by looking at this, you will automatically be able to tell very proactively that radius is having an issue and .1x process is having an issue. The last part of this command is probably one of the most important commands that we use for troubleshooting. The last part lists actually the client delete reasons. In 17.3, this is distributed by controller initiated deletes, informational deletes, AP initiated delete, client initiated delete. So it will not only tell you who initiated the delete, but it will also give you the reason code against why the delete was initiated. Maybe the data path plumbing failed, or AP itself flapped. That is why the client got disconnected. It may be that the client EAP timed out. That would be another reason. It will also list for you in the case of AP when it's not able to complete the four-way handshake, and therefore it's going to delete the client entry. So all of these very important data points. Similar to the AP, we can also verify the client plumbing path. You can use these individual commands, but there is also the option to view by just simply running a Showtech wireless client with the client MAC address, and that will provide all this and some statistics together. Now, we know the APs, we know the clients. The other thing that we typically monitor on a network device would be the resource utilization, meaning the CPU, the memory. So let's take a quick look at that. On the CPU, we can simply use a singular command, the show process CPU platform sorted, which will provide you the control plane as well as the data plane CPU utilization, all in a singular output. In this example, I have specifically filtered down to show the WNCD instances. As you can see, there are 5 WNCD instances, which is a 9840. Well, the utilization was not very high up in my lab, but this is some way of identifying which particular platform you may be on, how each of the cores are being used, and so on, and which process, because it is sorted, it's just the top users are listed right away. The next resource that is critical would be the memory. So the show platform resource is a command that will list you the current usage as well as list the thresholds that we have assigned. So typically when we are hitting 90%, it is considered a critical state and you will start to see those messages. But even at 80%, there will be warnings, slots that will get printed informing that memory usage is hit the warning threshold. In addition, we have this command called show processes memory platform accounting. In any sort of a memory issue, whether it's a memory fragmentation or a memory leak, this is one of the most key commands because it is going to list you hourly stats, weekly stats, monthly stats as need be for the various processes, how they're using it. A specific field to look out for is the max diffs calls. If you see a particular process incrementally make more of those max diffs calls, that's an indicator that you may have a memory leak in that process. One thing to keep in mind when troubleshooting CPU or memory are these are resources available and meant to be used. So CPU utilization going up in itself is not a problem indicator. For example, if I were to run a Showtech wireless on the 9800, I would see a CPU spike for a quick second. That is not a bad thing. The CPU is available for us to use. But if that consistently keeps going up, or if the memory utilization on a particular process keeps incrementing and it's never releasing some of the memory back, that's when you would know that it is a problem and you would need to troubleshoot further. But so these are some of these outputs. They are not a single instance. You'll have to run these outputs over multiple instances separated by some time to identify really if there's a problem going on or if there's just a fluctuating usage depending on the time of the day and the traffic on the network. The last output for memory utilization is the show process memory platform sorted. Again, just listing the basic command that you would look at to see where the system memory is at. Is it close to exhaustion, and also to identify the top users at any given point. Now, we have talked about all the control plane entities. We have talked about the resources, APs, clients, and so on. Let's spend a couple of minutes to discuss the data plane health. On the data plane, we have a very simple command called data path utilization that lists how many packets are coming into the box and how many are leaving the box. It's a good indicator to see in a real production. I mean, some of these numbers are from my lab, which is had only a couple of clients, but at a real production environment, if there is a lot of ingress, not enough egress, or the other way where there's some ingress but a lot more egress, this would be a very quick indicator of that happening. We also have one command for global drop statistics. This command actually has 50 plus statistics counted, but I'm only filtering it down to show you the wireless statistics. These are some of the statistics you would keep an eye on to see if there's kappa errors going on, or fragmentation going on, or if there's a wireless client failure. Now, besides looking at the global drop statistics, we also have more granular command to look at just the kappa per drop counters, which would be the AP or the DTLS tunnel related drop counters. As you can see in this case, we were having IPv6 tunnel not found sort of errors, nothing more, but any mobility flap or kappa AP join sort of issues, here's where you would see the access point drop statistics. This output here presents the similar data, but it is for the client. drop. So imagine the MDNS packet getting dropped. There's also a feature called UDN that was launched recently, and any UDS packet getting dropped also shows up because of P2P, peer-to-peer blocking. If you have any clients dropping traffic, that would be indicated here as well. So a lot of drop counters that indicate the details. Now, this is the last output within the data plane. Here, we are not looking within. So far, what we have talked about is the drop statistics and the data plane processing on its own. This is one output that will give you into view into traffic that is coming to the data plane, which needs to be punted up to the CPU. So, as you can see very clearly, the kind of packets that go up there are the cap mobility .11, .1x, which is listed here, some webauth, and all of the DHCP, which is also punted up to the CPU. So it's a very clear indicator to see which packet is having trouble getting punted up through the kernel. So a quick conclusion, the way you would go about in your environment, configure by following all the best practices and all the tech tips that were provided here. Once you do that, you run through the health monitoring for your different APs and clients and so on. Now, show log or the syslog is a good indicator of any errors that the system is seeing. If you see some errors or if you are concerned about a client, you can always go ahead and pull data for a given client to identify what's going on with the client. If you need to have more information for a given client, then use the debug wireless Mac macro and run the radioactive trace. In addition, you can simply use the web UI for it. Another important data point to collect would be the monitor capture commands, which is the Wireshark, which gives you a full view of the packets entering and leaving the box. If RA-trace output has all been collected and if you need to engage tag, a few other data points that would be helpful is getting an RA-trace internal level, since it's just a show command to run. The show texts that apply for the use case you're troubleshooting. Also, your own observations. How are you seeing the symptom? The frequency at which you're seeing the symptom. How are the users experiencing the problem? Details of that along with the trace on failure summary, specific timestamps where the problems were seen, and the specific MAC addresses or the kind of devices that have seen the problem. And in case of a crash, obviously the codem. With all this data, the attack case resolution should go much faster. That's all I had for today. Thank you so much. I hope you learned a few new things and you will be able to monitor and troubleshoot your environment in a much more efficient manner.